Now we are going to solve previous year GATE and IES questions on turning on of thyristor. This is really important because questions has been repeatedly asked in every 2 or 3 years from this topic. So you need to go through this lecture very carefully. You need to understand all the concepts and to know more about the concept behind these questions. You need to refer my lecture number 6, that is silicon control rectifier. So let's start the video.
Now we will solve the problem that has been asked in GATE 2007. This problem is for 4 marks. In this problem, this circuit is given and question says that a pulse transformer PT is used to trigger SCR. Okay, this is pulse transformer PT and this is SCR. SCR rating is 1.5 kV, 250 ampere and latching current is 250 milliampere. Maximum gate current is 150 milliampere with latching current 250 milliampere. Okay. On state drop of diodes, SCR, transistor and gate cathode junction is 1 volt. It means these are diodes, these are this is transistor, this is gate cathode junction, this is SCR. Okay. So drop across all of these devices in on state is 1 volt. So we have to find the value of this resistance R and voltage second rating of this pulse transformer PT. Okay, these two things we have to find. So first we will find the value of this resistance R. Okay, this is bit complex problem, but if you understand this problem completely, then you will be able to understand many concepts related to power electronics. So see this problem carefully. First we will calculate the value of resistance R. Okay. We know that this pulse when applied to the base of this transistor, then this transistor get turn on. Okay. And we know that turn on drop of this transistor is equals to 1 volt. So we have to apply KVL. Then we get 10 minus 0, this is 10 and this is at ground, so it is 0, is equals to move from 10 volts to 0 volts. So plus V1 plus Vc, and we know that it is equals to 1 volt. So that's why we get V1 is equals to 10 minus 1, that is equals to 9 volt. Now ratio of this pulse transformer, turn ratio of this pulse transformer is 1:1. So what is V2? V2 will be equals to V1 and that is equals to 9 volt. Okay. Now when this V2 becomes 9 volt and polarity of V2 is same like this, then this positive polarity makes this diode forward bias while this diode get reverse bias. Okay, so during reverse bias it will act as open circuit. Okay, and this capacitor also for this voltage source, this capacitor also act as open circuit. Okay, and this diode is on and we know that forward voltage drop of all the diodes is 1 volt. Okay, now we will apply KVL in this loop. Okay, so apply KVL, we get V2 that is equals to 9 volt, V2 is equals to VD plus VR plus this VGK. Okay, gate cathode drop VGK, and this VD is 1 volt. Okay, drop across diodes and gate cathode junction, all drops are 1 volt, and V2 is what? It is equals to 9 volt. So on solving this, we get VR is equals to 9 minus 1 minus 1. that is equals to 7 volt. So VR is 7 volt. Now what is R? R is simply equals to V by R. So voltage across resistance is VR. And what is current across resistance? We know that for reliable turn on, the current across gate terminal is Ig max. That is 150 milliampere. So it will be Ig max. So on putting this, we get 7 by, what is Ig max? 150 into 10 to the power minus 3. So on solving this, we get it is equals to 46.66 ohm, or in option 47 ohm was given. So answer is 47, which is nearly equals to 46.66. Now we have to find the voltage second rating of pulse transformer. Here voltage second rating means voltage into time. Okay, voltage into time rating. Now what is voltage? Voltage is 10 volt. Here 10 volt is given. Okay. Now what is time? What is time? Okay. This time is the time for which gate pulse is applied. And we have to apply the gate pulse till the thyristor get turn on. And when the thyristor get turn on, this thyristor will get turn on when the anode current reaches the value latching current. Okay, so we have to apply the gate pulse till the anode current becomes equals to latching current. Okay, or in short, we have to find the time during which this gate current, this anode current becomes equals to latching current. So how we can find this? Now to solve this, we have to take this part of circuit only. Okay, so in this part of circuit, we know that this is inductor current. Okay, and we know that inductor current is equals to anode current. So simply we have to find the inductor current. Okay, so what is inductor current? Now we will use the network theory concept, where inductor current at any time t is given by IL infinity plus IL0 minus now here in this equation IL infinity we have to find IL0, and we have to find this tau. First we will find IL0. We know that at t is equals to 0, initially inductor is not charged. That's why IL0 negative is equals to IL0 positive is equals to 0. Now what happens at t tends to infinity? I draw this circuit separately for your convenience. So this is thyristor, okay, this is resistor, this is inductor, and this is DC voltage source. So in this circuit at t tends to infinity, this is DC, okay. So this inductor will act as short circuit. So inductor gets short circuited. When inductor gets short circuited and at t tends to infinity, this thyristor get turned on, so drop across this thyristor is 1 volt. So we will simply apply KVL in this loop to find the value of IL infinity. So IL infinity is simply given by 200 minus 1 upon this resistance, that is 1 ohm, by 1 is equals to 199 ampere. So ILT, putting all these values, now we have to find tau. We know that tau is the time constant that is given by L by R. Here L is 150 millihenry, and what is resistance? Resistance is 1 ohm, so we get 0.15. Now we can write the complete equation of inductor current. ILT is equals to, what is IL infinity? That is 199 plus 0, IL 00 minus 199 e to the power minus t by tau is 0.15. Okay, and rearranging this equation we get, or simplifying this equation we get 199 1 minus e to the power minus t by 0.15. Okay, so if what we have to do to turn on the thyristor, we have to make this inductor current equals to latching current. So simply put, this inductor current is equals to latching current, that is equals to 250 milliampere. So 250 into 10 to the power minus 3 is equals to 199 1 minus e to the power minus t by 0.15. On solving this, we get t is equals to 188.56 microsecond. Okay, now final last this time we get, this is the time during which anode current reaches the value latching current, or we can say that this is the time for which gate pulse is applied. So now what is voltage second rating? That is equals to V into T, and V into T, and what is voltage? That is equals to 10 volt, this 10 volt, and what is time? It is 188.56. So what we get on multiplying? 1885 micro volt second, or in option 2000 microvolt second was given, so it is nearer to this value, that's why in option 2000 microvolt second was correct. So this is solution of this question. I hope it helps to clear many of your concepts.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.